Okay, hi guys. So in this lecture as well, we'll be discussing on the calculation of n factor in disproportionation reaction. So I hope you remember that in the previous lecture we uh, saw a formula in which to calculate n factor we had n1 n2 upon n1 plus n2 for disproportionate or other disproportionation reactions. Disproportionation reactions. Okay. So how do we actually derive at this formula? So we'll be first seeing that. So let's suppose I hope you remember that in a disproportionation reaction the same compound undergoes reduction as well as oxidation. Okay, so using the same example here again for the derivation of this formula. So let's suppose we have oxidation of M, and in oxidation M goes to plus N1 state and releases N1 electrons, and in the reduction stage what happens is M actually accepts, let's say, N2 electrons and goes to M minus N2 stage. This is the second reaction. Okay, so what will happen here is, if we multiply first reaction with N2 and add it with multiplication of second reaction with N1, what will we be getting? We will be getting something like M times N2 gives M plus N1 multiplied with N2 plus N1 into N2 electrons. Similarly, M times N1 plus N1 times N2 electrons would give us M minus N2 multiplied with N1. Okay, so if we just add up these two reactions, what we'll be getting is, first of all, let's cancel N1 N2 into N1 N2 electrons from both the sides. So then we will be getting M N1 plus N2, or rather N1 plus N2 times M, and on the right hand side we would be having M plus N1 multiplied with N2 plus M minus N2 times N1. Okay, so from this we can say that N1 plus N2 moles of electrons are needed for N1 plus N2 moles of electrons consumed or used in disproportionation reaction, for DR, which means disproportionation reaction. Hence N factor would be number of moles of electrons used or consumed in the reaction divided by number of moles of the compound. Hence we derive this formula. Let's take a look at some of the examples on the same. Okay, so let's say we have Cl2 providing OH minus here. This goes to ClO3 minus and plus Cl minus. So Cl was at 0 state, it goes to plus 5 state here and minus 1 state here. Okay, so what is the oxidation in this case? Oxidation is Cl2 going to ClO3 minus, and as a result we'll be needing how many electrons? Cl is going from 0 to plus 5 and there are 2 moles of Cl, so we'll be releasing, Cl will be releasing 10 moles of electrons, and in the reduction state what will happen? Again this Cl2 consumes 2 electrons to form Cl minus, balancing the reaction. Okay, so here what we can say is, in the oxidation state we require how many moles of electrons? In the oxidation state we require, as Cl2 is going from 0 to plus 5 and there are 2 moles of Cl involved here, so 10 moles of electrons are required in oxidation state. So N1 would be 10. This is the number of electrons for oxidation state or oxidation of Cl2, and in the reduction we will require 2 electrons, as 1 Cl is going from 0 to minus 1, so 2 Cl will require 2 electrons. Total number of rather n factor would be n1 into n2 divided by n1 plus n2. Okay, so it would be 2 into 10 over 12 or 20 over 12, which is 5 over 3. Okay, so let's take another example on the same. So we have sulfur plus we are putting NaOH in it, and this is converting into Na2S plus Na2S2O3. Okay, so here sulfur was in 0 state, it goes to -2 here. And what is the oxidation state of sulfur in this compound? Oxidation state would be, as we can see that 2 Na plus are getting attached to S2O3, so S2O3 would definitely have a minus charge. So let's say oxidation state of sulfur in this is X, so oxygen is fixed, which is -2 here, equals to -2, so 2x is equals to -2 plus 6, x is equals to plus 2. Okay, okay, so oxidation state of sulfur in this case is plus 2. So in oxidation state, number of electrons released by the sulfur atom would be, from converting S0 to S2, would be 2, and for reduction, number of electrons gained by sulfur atom for converting itself into from 0 state to -2 state would be again 2. So n factor for sulfur would be n1 n2 upon n1 plus n2 for disproportionation reaction. Okay, this is an example of disproportionation reaction. Okay, so this would be nothing but 2 into 2 over 2 plus 2, that would be n factor would be 1. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples on calculating the n factor in case of disproportionation reaction.